Welcome all to the ACIL, American Council of Independent Laboratories, webinar series on electromagnetic compatibility. This is the last webinar we will have in the calendar year 2016. What I am showing now in front is what we've gone through this year already, and including today. So we've had 6 webinars, so we recorded over 6 hours of material on updating, in particular, right from meetings that I attend or chair and so forth. So in February, we picked up what was happening in the U.S. National Committee of the International Electrotechnical Commission. And I did on March, I picked up what is happening in the Smart Grid Interoperability Panel on their Electromagnetic Issues, Interoperability Issues Working Group. EMI is not, the I is not interference, it's interoperability. And in June we picked up what was happening in the North America standards, in particular ANSI Accredited Standards Committee C63 on EMC. And then on June, and again today, we're going to talk about the IEC Advisory Committee on EMC, which reports directly to the Standardization Management Board of the IEC. The Standardization Board manages the entire technical operation of the IEC, and they rely on several advisory boards as directly reporting to them issues on various subjects like safety, human exposure, and so forth. And in particular, the Advisory Committee on EMC, as it says, reports to them on issues that comes before the Advisory Committee or issues they may send down to us to review, and I chair that. And then on November, to sort of encapsulate the international work, I talked about what's happening in the International Special Committee on Radio Interference, CISPR, meeting that I was in China for 2 weeks. And in fact, just got back 3 weeks ago. So with that, this will conclude then the webinar series for 2016. I'm in the process of putting together the dates for the 2017 editions of these. May not be all of these, but I may switch around to some other major EMC committee activity. In fact, I might even get into some particular standards, and we can talk about them as we go along. So with that, I think it's time to launch into today's, which you can see is to review the IEC meeting we held in Frankfurt, Germany in October 6th and 7th in particular. So let me close that and bring up the agenda. What I normally do, come back up. What I normally do is read from the agenda, and I have hyperlinks to all the documents, and we see what we can conclude in an hour. So you can see there's the header of the agenda, and I'm going to go into just certain ones because there are 33 presentations and we simply don't have enough time. So when I open up some of these PowerPoint, I will probably pick 1 or 2 pages and then hurriedly move to the end. In other words, it's going to be a little pick and choosing, but I will try to highlight the best I can. So the regular agenda is as shown. Item number 3 is our membership, and I'm going to bring that up just to give you a sense of how many people are involved, which are quite a few. This link should all work. Let's make it big enough so you can see it. This is a picture, photo gallery of the people. And it went a little too fast there. So there's myself as chair, the vice chair, who is also the chair of TC77. EMC is Hiroyuki Osaki, very good and smart individual. Our secretary is from Geneva. We have some new membership, and that's why some of these photographs have to be updated. TC13 is on metrology meters. and in particular they are the people that work with smart meters for using power line communications to control the information. 77A is low frequency EMC. Manuel de Jager is very good. He's from Belgium. 69 is the electric vehicle, and Jacques Delbel from France is a member. Then we have other members like TC22, which is grid connected power inverters, what we would call AC/DC supplies, and they worry about controlling those. 77C is high energy transients, and you could read that to mean electromagnetic pulse from a nuclear blast, for example. I missed one up there, TC46, that's cables. It's very interesting. Cables, although it's a passive device, they worry about connector shielding effectiveness. Obviously, shielding effectiveness of the cable itself, if it is coaxial. And they consider themselves an EMC operation because their cables are largely used to control the antenna effect for immunity, for signals getting into the communication line, or for emission signals getting out to disturb other electronics around. And then we have some appointed people from the SMB, and what we try to do there and what they try to do is to give us a international flavor. So we have people from Korea, we have people from Japan, and so forth. 121A is works with, well, it is a, how should I say it, they worry about power supplies, and I'll get to that in a minute. Li Nai is from the China Electric Power Research Institute. She gives us quite a bit of information on the regulations for meeting compliance on conducted emissions and as well as radiated in China, and how the regulatory structure is changing, which is dramatic, by the way. I don't have time to go through all the things she mentioned. The good news is a lot of it's moving towards manufacturer being self-declared in certain aspects. And we have others. I'm just not going to go through the entire. 65A is product assembly, assembly line control for anything that's on the assembly line. 77B is high frequency, classic 61000-4-X series. And then we have a couple of other folks which TC62 is medical EMC. We have a good guy from Siemens there. And then subcommittee A of CISPR, which is measurement instrumentation and measurement methods, as well as measurement uncertainty. So I thought it was worthwhile to, at this last time, we have a webinar this year to sort of show you what the players are. We all have terms of office. I'm not going to bring that up. There are some changes, and I'll show that when I give my CISPR report, for example. 3.4 is a caretaker program. Each one of those individuals are responsible for giving us any information that impacts EMC of their product or other products that may have an interrelationship with or a disturbance. So I won't bring that up. It's pretty straightforward. 3.5 is I won't bring up, but I put together what I expect for members to be active. And that means they show up at face-to-face meetings, they deliberate, and as well as the webinars, and you can't sit it out. ACEC does not do webinar meetings. We need face-to-face because we're there for solid 2 days, going over 30 topics that we need everyone to be heard. And as you might imagine, some of these folks do not have English as their native language. And to hold a webinar with that many people, it just frankly would not work. So I've decided it will be face-to-face. On the other hand, any actions coming out of the meetings will be handled by a webinar, and the next one is the 8th of February 2017. I want to get into the reports now, which should be the heart of the meeting. I'll start off with 7.1 here, open up my report. Again, I'm not going to go through every page in the slide, but I think it's useful to make that bigger. These are the people that are the crux, but you notice right there, my name, next to my name, Bettina Funk from the Swedish Telecom is the new chairman as of the 1st of last month. My term of office is up after 9 years, and you know, that was enough. She's a very, very good individual for running a meeting. She's obviously a woman, and much younger than everybody else is on that list. Then we had some changes at subcommittee level, which the names may not mean anything to you, but it was just, they all met their term limitation except for Martin Wright down at the last bullet item. Gary Pettit used to be with Intel in Washington State, or Oregon, I think it is. He moved in as a new person, so his possibility of being his term running up to 9 years, which is actually the 3-year terms, and there we have a chance for 2 additional nominations. All right, we have a lot. The reason why CISPR is special is that we have more than national committees that vote on their documents, and there's a list sitting in front of you. We have good relationship with the ITU, as shown there in the 4th bullet item. We have, of course, people from the European Broadcasters Unit as well as Senelec. ECMA at the bottom there, we used to be called the European Computer Manufacturers Association, but now they went to just the acronym ECMA. And then, of course, ETSI, the European Telecom Standards Institute. Not going to go into how many times we hold meetings. One of the key activities we had over this recent year is the concern with the power line communication necessary to run smart grid operation, which operates roughly around 80 kilohertz. And the question is, they want a high signal to noise ratio. And I'll talk about this later on in the 77, bring up the 77A material. Well, the noise part of it is the conducted noise coming out of the AC/DC converters of all of the products. In fact, can you even mention a product now that doesn't have an AC/DC converter? When your laptop is classical, but it has an external brick, most of the electronics that don't have something external have an internal to the case of the product. And the question is, can we control that so that they have a good signal to noise ratio, or should they build more immunity into their signaling system? And that has not been solved. And I'll talk about that when I talk about subcommittee 77A. Wireless power transfer continues to be a high activity in the ITU as well as in CISPR, as well as TC77. The concern is, and maybe it's a new acronym, SRDs, short-range devices, things in close proximity. There is an immunity test method that's going to file and draft the international standard, which I'll talk about if I have time. And these are radiated, so the measurement will be using a magnetic loop antenna, and that is new too at these frequencies, because some of these frequencies, again, are below 150 kilohertz. And then the last bullet item, we're starting to be heavily involved in robotic technology. And the ACAR is the Advisory Committee on Robotic Technology, as a similar advisory committee as the Advisory Committee on EMC, ACEC. Don't want to go into detail. We have a lot of liaisons that give reports at our meetings. We have joint task forces on use of fully anechoic rooms, transfer select magnetic use of TEM cell measurements, immunity and emission, and then we are also co-branding with 77B on reverberation testing. There's a lot of links I put together, and I don't propose to show them now. And the last slide of all the presentation has to be, what do they expect ACEC to do? In this case, it was just for information. Okay, let me close this down and move on to some of the other reports. I'm going to bring up Subcommittee A on instrumentation and measurement methods for emission. And it's very detailed, and we clearly won't go through it all, but I thought it'd be useful just to show you some of the things that they do. And there's the basic CISPR 16 and 17. You can see the 4 areas of this particular committee. And he always gives, what documents, which I'm not going to go into right now. Just looking at the active projects for instrumentation, Working Group 1 handles that. We're still working on site validation, believe it or not, especially in the antenna calibration and the antenna pattern needed to be met to do full investigation of a chamber you're trying to meet, whether NSA or the so-called site VSWR method. And I don't see anything that, and by the way, every time we do a project, we have to consider what should be added to 16.4.2 as well as 16.1.4 on uncertainty. And there's the group. Working Group 2 now is measurement methods. A lot of it is just like LLS, large loop antenna system. It's the magnetic measurement, 3 orthogonal loops where you put the product inside and you measure the emissions of all 3 axes. And coupling devices, capacitive coupling devices, capacitive voltage coupling devices. And at the bottom there, there's now an emphasis to look at what's happening below 30 megahertz. And of course, I just mentioned that we'll probably go down to 9 kilohertz. And nothing much to show here. I already talked about the Joint Task Force, so it's 77B. And there's intra-CISPR coordination, because our subcommittee D is automotive, and they are concerned with site validation for a chamber that's totally reflective, where some of their immunity measurements are made, which largely goes in the same way in which mill standard testing is done on a conductive bench and so forth. And the question is, what do you do with room resonances, and how do you show where they are, and so forth? So there's no action of us. Let me close that down. Close this. CISPR B is industrial, scientific, and medical. There was no report. So, and CISPR H is the generic emission. I just want to point out one or two things there. We'll bring up Burini's presentation here. Okay, let me put it full screen. The generic emission standards for CISPR doesn't have a CISPR publication number. It's IEC 61000-6-3. This is for residential, commercial, and light industrial, and 61006-4, which is industrial only. As you might imagine, there's concern there if is it sufficient, or there's been discussions maybe we should have another set of generic emission limits for just commercial and light industrial. There was a third set. Fortunately, that has not made sway, so that will not happen. And this chart, which is an eye chart, I apologize, but on the column third from the right is whether it's a Class B or Class A. Class A usually have more emissions than Class B. Its limits, and then it goes down on the left what is presently in some of our standards, CISPR 11, 22, 32, and so forth. So he gives us a nice update of where the generics sit with respect to what is published in the product standard, which is, of course, what is called out in regulatory authorities. And again, I'm going to, they're into photovoltaics, can't even speak, huh? And ELV, and extra low voltage lighting in the house, and what should be limits on that. They have a database of radio services, and you can kind of see that there is some new areas of work. For example, below 30 megahertz, what should be emission standards generically, or should we just rely on what the product committees come up with, which usually takes precedence? And I think I'm going to close that. We use them quite a bit because they also have a model that you can calculate limits and extrapolations, at least to first order effectively. Let's go over to 77 side of the house. My friend Hirioki, and see if he comes up. I said already that there's 3 subcommittees that are involved, but this is at the 77 level. When I gave the CISPR report just a few moments ago, that is at the CISPR level, not at subcommittee level. So there's just a few things that he wanted to point out at the higher level of what's happening in TC 77. Of course, there's the who's who. And you notice the terms of office are now extended out to 2019. So they will not have a change of leadership with term limits that we had significantly in CISPR this last October. Bunch of, I just think the usefulness is looking at the titles. Of course, definitions is always the first one. Classification of electromagnetic environments, the 2-5 one especially, has been updated, and I'll talk about that very briefly. Everyone's familiar with the 61000-4 series. And 4-1, by the way, is how to use 4.2, 4.3, 4.4, 4.5, and so forth. I find that as a very useful document to set the stage of what you might want to say with the clients if you're a testing organization, because it's easy. It's more or less an easy read with tables that you can pick which one might be used and which one is maybe optional and so forth. There's something on installation, and they have their own generics. And 2-5 is again, notice the publication date is kind of old, and they expect it to be published in end of September. I haven't looked yet, but I think I saw a announcement that it has been published. And that's a very useful document because it gives levels of radiated emissions at certain distances from a whole range of transceivers and things of that nature, transmitters. It goes on for pages and pages and pages. And that is useful then for setting limits, setting test levels when you do, for example, a radiated immunity test. And there's maintenance activities, and they're looking at below 150 kilohertz. The world's looking at that. I'm trying to see if there's anything I want to point out here further. You notice that the environment is covered by 77 because it's a higher level, and of course environments apply to the work of the committee. Working on the burst repetition frequency, everyone knows 100 kilohertz even is not particularly represented. It's sometimes 1 megahertz. And the question always is, well, do I have to have new instrumentation? Right now, you have the choice of 5 kilohertz or 100 kilohertz, but they're discussing maybe going up above that to be more realistic. And that's all you need to say there. And let's get into the low frequency EMC 77A. And this will also cover what's happening between 2 kilohertz and 150 kilohertz. All right. Okay. Emmanuel is from the Belgian National Committee. He's very active. He's a university professor. There are several projects, and you know, the flicker and the voltage fluctuation and dips and short interruptions, all those are special tests that are technique. And all he's saying right here is that either it's current or it's the committee draft or vote stage. And you can see on the voltage dip and short interruptions, the generator specification, the rise and fall time, especially the inrush current when you turn the product on. There's a lot of controversy there. So it'll be interesting to see how that turns out. Work on this is on dispersed generation systems in the low voltage network. And you know, there's distribution and there's transmission level of power. And you don't have time to go through that, but it also covers, by the way, photovoltaics again. You can see at the bottom of that slide, low voltage grid and the PV converters and small wind and hydro turbines. In other words, they're into concerns about how to measure renewable energy sources. And of course the usual harmonics and fluctuation, just kind of going. And I'm going to talk about this a little bit later on the what's happening in this product. They have liaisons with SIGRI, which is, by the way, the high power research group. Let me get to, yeah, this is what I want to move to. There's the working groups in A. I'm in particular turning attention to working group 8. Luc Berthaud is the chair, and the presentation, Emmanuel's presentation to ACEC was, we need advice, please help us. And that's what ACEC is there for. They've been working very hard now for well over a year, and CL's compatibility levels. In other words, I mentioned, how do you control what the grid connected power inverters put on the power line, and to not disrupt the power line communications that's used to control smart grid, for example. And the point maybe I should bring as a side, since most of the power in the European Union is buried, they can't use wireless, for example, to control the smart or get data from the smart meter. Well, in our country, most of our plant is aerial, and our smart grid installations tend to use Wi-Fi. But obviously you aren't going to use Wi-Fi trying to get a signal through the earth. It's not the best way to do things. So the NIE is non-intentional emissions. This is, they seem to make a distinction between a signal that is transmitted like power line communications versus just noise. And of course, in the CISPR world, we're worried about anything you put on the power line that could radiate and cause disturbances for nearby electronics. But we're talking here about the signal across the two parts of the power line. And what we worry about in CISPR is how that is transformed into common mode in the same direction on those two conductors, because that's what's called an antenna. And then it becomes a radiating structure that might cause harmful interference to radio services. So we have to kind of keep that straight, that this is talking to two different ways of which the signal is placed on the power line. And this is a busy curve, but I just point you to the 50 kilohertz, about an inch from the right. You can see the green line and the blue line. These were proposed limits to be placed on the power line, and you can do the math looking at, they're sometimes like up to 40 dB different, and it's above 30 kilohertz that this diverges with no consensus. And that's what they've been working on now to try to get a consensus, without much success at the moment, because when they asked the national committees which to use, they have to, the national committees came back saying, in fact, I think the next one is, yeah, right here. 25 national committees said option A or B. A is the one with the higher level. 7 voted in favor of just using A because they're probably more from the power, the AC/DC converter side of the house. And 8 voted in favor of option B, hardly a mandate. And then 10 noted they didn't reach a consensus on either of them. And in fact, some of those 10 said, well, let's try our own set of limits, and they turned it in as part of their comments. And you can see that has led to frustration of not being able to move this forward. The reason why this is important, this was brought to the attention of the Standardization Management Board about 1.5 years ago, and they passed it on to ACEC, and ACEC looked at what was happening, and we suggested which technical committee should be involved and so forth. But we, in the advisory committee, we don't do technical work. We review some of it, but it's not our business. So all went back on Working Group 8 of 77A. And they're meeting every 3 or 4 months, and there's like 50 or 60 members on that committee. So we have to stay tuned on what they come up with as a compatibility level between 30 and 150 kilowatts. It's the bottom line. I'm just going to move forward on this because we have other things to capture. Well, I think you get the sense of the real urgency in coming up with a set of limits between 30 kilohertz and 150 kilohertz. Probably wireless power transfer for automotives is in the 80 kilohertz to 90 kilohertz region. So we got a lot of stuff going on in below 150 kilohertz that we weren't really into in the past, and now we have to be into it for a couple of reasons, one of which I just said and one I just showed you. Let's go to the B report. This is our usual 61004-X. Let's bring up Louise' presentation here. Okay. There's the working group activities, who they coordinate with. I mentioned 121A already on low voltage switchgear. Don't want to go into 410, well, no, let me get to 4-31 is very interesting on AC main sport. How do you measure broadband conducted immunity? How do you launch that kind of signal? And then they had meetings. I want to get to, when you look at 4-39, that's a sort of a buzzword now. Radiated fields in close proximity. I read that to mean near field, where you bring the source close to the product that you're illuminating for an immunity test. And there's obviously things you have to be concerned with. And when you deal with a very complex near field, when you try to radiate, in which axis are you radiating, and what's the complexity of it, and how do you generate a fall off if you want to measure further away or closer in. I'm looking forward to that document. I have it at the, it's in the drafting stage and editing. It may have already come out, I haven't had time to check on that, but it's easy to go to the IEC website. When you go to the store in the IEC, you type in 61004-39, and you'll find out if there's a published version of it. And of course, the store, then you would buy it, but at least it will come up and tell you if there's a 2016 date on it, which is what I do when I work with clients. 4-2, it's stable through this coming year, so they're just collecting things they might want to do. One of them, there will be a U.S. contribution, by the way, on testing for problems in the field when a computer seems to malfunction. One of them is, for example, if you have a computer and you put it into a docking station, there is an electrostatic discharge there that's quite different than using a gun. And in C63.16, we just published what do you do with these special tests that will be more representative of the product surviving an ESD event in those cases. And I've asked the C63 committee to put together a proposal for an addition to 4-2. We'll see what happens there. 4-4 is stable until 2018. So for the purposes of this webinar, if its stability means that it cannot change with a new addition until that year. Now you might ask, well, is it the first of 2018 or end of 2018? The answer is yes. It could be any place in between. But I wouldn't worry about something that's happening in 2018, especially for test laboratories, because you won't have to judge whether you need to have a different calibration technique, or you may have to have an applique that applies to your test equipment you have now. And the people that write these things have representatives from test laboratories, so and even, well, instrumentation manufacturers. So presumably they know the impact to their customers, and you don't want to change you don't want to have it to change every instrumentation that you've been using for years for immunity testing, and that would be brought up during the deliberation. So most of these are improvements from the repeatability and reliability, but occasionally something sneaks in that will require updated equipment, and that's why the National Committee should be really looking at these voting documents and call attention to that if there's a major impact on test labs, for example. Surge is the stability date was this year. There's a report, RR, that was circulated in I guess September, and I have not seen the CDB committee draft for vote, but again, what I would do is look on. I have access to the IEC pages beyond password, and I guess I could look these things up. But right now, just for your information, if it says CDB, that means that has to pass, and then a final draft international standard has to be made. So even if it was a perfectly approved with the 2-3 month voting period, and it would have to then look at what would be needed to go to the final draft. So we're talking about probably late summer if anything comes out on 4-5. And I'm not going to go through all these here. But you can see it's the usual, the group. And this is the work going on in the transverse electromagnetic testing. Right now, by the way, the 4-20 only applies to battery-operated equipment being tested for immunity. And by the way, they call that small EUTs, small EUTs. And a large EUT, in their terminology, is a EUT that has a cable connected to it, like a power line. So, very curious use of the word small and large, and so forth. Okay, let's move on to this one. These are pretty key in the presentation here for the webinar. 77C, I'll just show you the title of it. This is high power transients. And high power is different than high energy. High energy, you know, power times time is energy. And since these things are picoseconds to nanoseconds to microseconds, there's not a lot of energy, but there sure is power if you look at the amplitude of the signal that's applied to a product. And I'm not sure they have anything that stands out. Again, high EMP, protective devices. Oh, the second bullet item is kind of interesting. When we do shielding effectiveness of a room, a chamber, we usually put a transfer antenna inside and a receiving antenna outside. Well, the problem with that is, or just the vice versa. And yeah, let me repeat myself. Usually it's the transmitter outside and the receiver inside. Well, if you have these high energy pulses, that could cause quite a disturbance, for surrounding areas outside of the room. And to sort of counteract that, you're putting the source and the antenna and the signal inside and checking outside, and now you have the situation of measuring these pulses in a noise environment with the receiving antenna outside the chamber. So that's why they call it inside out. Again, it's like their use of the word small. It's kind of curious. And this one here is interesting. This is IEEE 1642 that was converted into the intentional EMI test method. And this is, you can go on eBay now and find a secondhand transmitter, and you can rig up an antenna, put it in a briefcase, and walk up to an ATM machine and trigger it such that it will destroy the circuit that might be counting the money correctly. So the concern here is terrorist use of, in this particular standard, they show how you can do a better design to keep away from this kind of, I'm not saying what I would say, like a low power, but since it's a short separation, it has a major impact if it's unprotected. So we have our EEE standard on it, as well as the conversion to the IEC standard. So that's all I want to say about the high power stuff. Yeah, let's go down and see what we got left on the agenda. It's important. I'm just going to pick and choose here. We got roughly 18 minutes left. TC13 is the one for the metrology, the meter folks. Maybe I'll just bring up a couple of things. And TC13 is concerned because they want to have a low noise source, a low noise ambient on the power line, and therefore they got involved with the grid connected power inverter folks. So they have taken a position, and we don't have time to go through it, that they agree with the compatibility level between 2 and 30 kilohertz, but they have reservations between 30 and 150, as do others. But I just wanted to at least point out the TC13 is in that game, and there's their title. They're metrology people, electric energy measurement and control. And that's really all I want to bring up on their presentation. 22 is the power inverter, folks, and there's the match between the compatibility levels. And I just wanted to point out, if I can find it, let me go back here a minute. 22E is involved with EMC, but 22F is heavily involved, and that's high voltage direct current. The transportation of energy across large distances. And let me just see. I think they had they handle, by the way, uninterruptible power supplies as well. The point being is they are saying, look, there's a billion with a B Bravo products out in the market that have put signals on between 2 kilohertz and 150 kilohertz because there's no limits that applied, except in some cases like induction cookers there were below 150 kilohertz. And there's no way you're going to suppress what is there to give a better signal-to-noise ratio for the control of the smart grid and the smart system, if you will. And some people say, well, why don't you just put a filter and everything? Can you imagine putting 8 billion filters out there? The other thing I learned too from the group is that these filters, and I'm surprised, generally a filter in a product is good for about 15 years. And if you want to have the same efficiency of that filter, you'd have to replace it. Well, again, that's why filters didn't get a good support here, because there's no way you're going to go out and replace 8 billion filters, even if you put filters in the first place. So that's kind of the both sides of the story at this point. So I think that's all I want to show on 22. 46 is the cabling people. Let me just, I'm going to just bring these up and at least show 1 or 2 slides. Because what I'm trying to do is show you the breadth of what we have to cover, and looking at the scope. And this is saying, well, why is there EMC on a passive device? Well, here's what's in their scope. Requirements for quality assessment, metallic connectors, wires, wavelines, RF connections. You can read the list for communication networks and cabling. Well, we use shielded environments of cabling all the time for both suppressing emissions from cables as well as pickup as a receiving antenna. And therefore, Working Group 5 handles any aspects of electromagnetic compatibility, and obviously what they're doing is trying to show how you'd measure SE shielding effectiveness of connectors as well as their cables. It's a very interesting activity, and I don't have time to go through it. Oh, one thing had just kind of just a curiosity. What their standard says that pick whatever the subject was, up to and above 6 gigahertz. So I raised the question in the meeting, well, up to and above could be 300 gigahertz. And you got sort of this stare, deer in the headlight. So one of the things they took on as advice from the advisory committee is to put a number there. If it's really meant to go up to 6 gigahertz, say it. And they're taking that on advice right now, because right now when you say up to and above, it doesn't mean anything, at least to some of us readers. Okay. I think that's all I want to say with that. Let's close that down. 61, I don't want to bring up, it's not as interesting. 62 I want to bring up because there is activity on one of the documents, the classical document. Make it full screen. Bob Sitzman works for Siemens. He really spends 110% of his time on TC62. Some of you may be familiar with the original EMC document that was a collateral to the safety document 60601-1-2 back in 2014 when it was published, and had a section, Annex J, on electromagnetic disturbances, which is the EMC part of it. Well, it's been, that part has been divorced and put into a new technical report, TR 60601-4-2, that was published in May of this year. And now all the electromagnetic immunity and performance material is there, and not in 60601-1-2. So if you do that medical device testing, you really need this technical report 4-2. And there's several reasons why that happened. You know, one of the obvious one is 60601-1-2 is a safety standard. And what is EMC doing in a safety standard, although there's functional safety, you understand. So now it's very clear the safety part of it, and it's very clear the EMC, and we have 2 separate documents for that. So this is really the takeaway I'd like to have you have for TC62. And close that down. What else let me bring up? Let me bring up 69 on electric vehicles. We always have an interesting discussion on electric vehicles. Okay, it's a short report. I guess the point I take, again, a simple takeaway is there are two ways of looking at charging a vehicle. One is where the charging system is on the vehicle or part of the vehicle. That's called on board, and all you're doing is supplying 220 volts to this charging unit. That's part of the vehicle. And the other part of it is if it's at a charging station in which you simply have a cable that goes to your battery from the charging station. And from an EMC perspective, there are two different environments, and they have different emission, obviously, even radiation patterns, so to speak. So that's really what we try to work on. Well, why they're trying to tell us, what to do with is if there's any need for EMC, I should say. And then, of course, there's power supplies that also work with the charging station electronics. And don't forget, some of these stations could be running at 220 and for fast charge. And it's quite interesting. From an EMC perspective, by the way, they don't do it for this subcommittee, but we're concerned about wireless power transfer, because that's how you can charge a car, by having a magnetic loop in the ground and a magnetic loop on the bottom of the car. You drive them over there and you have essentially a transformer transferring the power, but it's an open air gap, and clearly it's not a shielded environment, and therefore problems possibly for radio interference from something nearby. Okay, let's close that. What else? Let me just briefly talk about 106 because we're kind of running out of time. This is the human exposure. I am the liaison with the TC 106, which handles human exposure. Get this bigger. Okay. And I'm going to flip to this page right here. In fact, this page, excuse me. They have the strategic objectives for 3 to 5 years. You can read the titles across the top. And the one thing they're working on that brings ACEC into close proximity. By the way, the reason why the two are kind of simpatico is they measure an electric field. We measure an electric field, for the CISPR side at least. But they then do something with that electric field with how it penetrates a simulation of a human brain tissue. And they call that specific absorption rate. But the two organizations are in the business of measuring electric fields. But again, TC 106 then goes further with that information. But they're working on a guide for the standard protocol to do this, and that guide now is going to be administered by ACEC, because only advisory committees can put out guides. And we're really looking forward to that. And again, that's all the time I have for this. By the way, the work they do is measurements as well as computational activity. So they can predict, or at least try to predict. They do it with vehicle antennas mounted on the rear, mounted in various ways. Again, we just simply don't have time because I want to kind of get to the end here. Looking over in Clause 8, there were representation from the ITU, International Telecommunications Union, the telecom sector. They're working party number 2 in ETSI. And I always give a presentation on what's happening on the EMC Society standards, because we have this dual arrangement with the IEC for publishing an IEEE standard with both the IEEE logo and the IEC logo, and to have joint work to amend that, for example. And that's took 10 years to get into effect. So there is a close relationship between IEEE, on the official, and the IEC on how we do work together. So I don't want to necessarily bring that up. I think to conclude, I want to go to 11 on looking at the young professionals, but more importantly, I want to show the there is, the link should come up. No, that's not the one I wanted, sorry. Let's go on to 13, the ACEC presentations. We've been for this series of webinars talking about various meetings and the outcomes of the meetings. It turns out that there is workshops that ACEC puts on around the countryside and around the world, so to speak, and the last one was in at the EMC symposium in Ottawa, and I'm just going to sort of go through the titles here. Dr. Radowski and myself gave presentations. He gave one to start off, what is the advisory committee? Then I talked about CISPR. He talked about 77 and the concerns on that 250 kilohertz band. He picked up on the electric vehicle, e-mobility it's called, and then I picked up the medical device, TC62, in particular calling out that technical report where the EMC requirements are located now. Then I gave an overview of human exposure, TC106, and that's a 3-hour workshop we held. All of these, if I clicked on it, they would open up and you could see them. It's PDF, but that's just maybe another extension of what you might want to find out about the advisory committee. Again, I guess I could have pulled it up and see what comes up. Just at least try one out. This is what is ACEC, and again, it's pretty good. It has the org chart of the SMB, for example, and who's on it, and so forth. We don't have time to go through it, but I would suggest that this is a interesting reading. The last thing is that website I showed you. Up here. Oops, wrong one. Let's try this web link. That's it. On the IEC homepage, if you go on the homepage in the bottom left, it says technology sectors, and one is electromagnetic compatibility. And this is the page that pops up. And it is very good in anything from the basics, what is EMC, up through the standards that are used and, the smart grid applications, etc. And I use this even to tell my colleagues that are not very familiar with EMC, why don't you just read it? It's easy terms, and it might be something for you in the testing organization to give your clients to learn more about what you are doing from an EMC testing perspective, or just what is EMC in particular. And I've even used it to give to some of my friends when they ask me, what do I do? So I just bring it to your attention. I think it's a nice way to end the webinar series on the advisory committee, because that encompasses everything from IEEE to the IEC to European Telecommunications Standards Institute, CENELEC, and so forth, that give reports and have issues that we try to resolve. And it's an international organization. Obviously it's headquartered in Geneva, and even it's so important that we have a technical officer of the IEC assigned to be the secretary of this committee, which tells you something about the importance the IEC places on it. So with that, I am at the point of concluding. We have gone through as much as, the next meeting is not of interest right now. So I would like to wrap up the year 2016 with, again, thank all that have been on the live presentation. But just to note that all of these are recorded and are available on the ACIL link and ACIL link. And if you have problems trying to find it, Bob Littenweiler will be more than happy to help you and assist you getting to where to pick these up. So we've gone through about 6.5 hours of EMC activity for the year, and if you say how much of that is current, I would say 80 to 90% is current, because as you know, the standards world doesn't change overnight. So I again appreciate ACIL for allowing me to present this, especially to the conformity assessment section, and to Bob for his being helpful in sending out the notices and always being on guard to help me set up and give me control of the screen here. And to Beth Horan at the ACIL office, and essentially everyone that's involved with CAS has been very helpful and supportive of the work. For next year, 2017, I'm in the process of putting together another series following major meetings. And I haven't got to that right now because some of these meetings are still being planned and dated. And as soon as that happens, we will send out the usual notice that I showed at the start of this webinar, and to get the word out. And for those that want to get caught up, even what's been done this year, again, I encourage you to contact Bob to get the links to do that. So with that, I wish you all a good holiday season, and I look forward to even a better new year. This is Don Heerman, Don Heerman Consultants, a help and aid to the conformity assessment section. And with that, I close the last webinar of the year.